But behind closed doors, I'm a fool for your love.
Chapter 3, Network Protocols and Communications. Communication fundamental. A network can be as complex as devices connected across the internet or as simple as two computers directly connected to one another with a single cable and anything in between. Networks can vary in size, shape, and function. However, simply having a wired or wireless physical connection between end devices is not enough to enable communication. For communication to your device must know how to communicate. Rule establishment. These rules or protocols must be followed in order for the message to be successfully delivered and understood. Protocols must account for the following requirements: identify the sender and receiver, common language and grammar, speed and timing of delivery, confirmation or acknowledge requirements. Message encoding. One of the first step to sending a message is encoding. Encoding is the process of converting information into another acceptable form for transmission. Decoding reverses this process in order to interpret the information. Message formatting and encapsulation. When a message is sent from a source to destination, it must use a specific format or structure. Message formats depends on the type of message and the channel that is used to deliver the message. Letter writing is one of the most common forms of written human communication. For centuries, the agreed format for personal letters has not changed. In many cultures, a personal letter contains the following elements: an identifier of the recipient, a salutation or greetings. Message size. Another rule of communication is as the people communicate with each other. The messages that they send are usually broken into smaller parts or sentences. These sentences are limited in size to what the receiving person can process at one time. An individual conversation may be made up of many smaller sentences to ensure that each part of the messages is received and understood. Imagine what it would be like to read this course if it all appeared as one long sentence. It would not be easy to read and comprehend. Likewise, when a long message is sent from one host to another over a network, it is necessary to break the message into smaller pieces. The rules that govern the size of the piece or frames communicated across the network are very strict. They can also be different depending on the channel used. Frames that are too long or too short are not delivered. Message timing. These are the rules of engagement or messaging timing. This method determines when someone is able to send a message. Flow control. Timing also affects how much information can be sent and the speed that it can be delivered. Response timeout. If a person asks a question and does not respond and does not hear within acceptable amount of time. Message delivery options. A message can be delivered in different ways. Sometimes a person wants to communicate information to a single individual. At other times, the person may need to send information to a group of people at the same time, or even to all people in the same area. The protocols. Rules that govern communication. A group of interrelated protocols necessary to perform a communication function is called the protocol suite, implemented by hosts and networking devices in software, hardware, or both. Protocol stack, content layer, rules layer, physical, open. Network protocols. Network protocols defines a common format and set of rules for exchanging messages between devices. Some common networking protocols: Hypertext Transfer Protocols or HTTP, Transmission Control Protocol TCP, or Inter-Protocol TCP. Protocol interaction. Communication between a web server and a web client is an example of an interaction between several protocols. The protocol shown in the figure includes HTTP is an application protocol that governs the way a web server and a web client interact. TCP is the transport protocol that manages the individual conversation. It is responsible for taking the formatted segments from TCP, encapsulating them into packets, assigning them the appropriate address, and delivering them to the destination host. Protocol suite and industry standards. Protocol suite is a set of protocols that work together to provide comprehensive network communication services. A protocol suite may be specified by a standard organization or developed by a vendor. TCP or IP protocol suite. The individual protocols are organized in layers using the TCP and IP protocol model, application, transport, internet, and network access layers. Application layer, name system, domain name system, translate domain names such as cisco.com and into IP addresses. Host config, bootstrap protocol, enables a diskless workstation to discover its own IP address, the IP address of a bot server on the network, and the file to be uploaded into memory of the machine is being superseded by DHCP. DHCP, Dynamic Host Configuration Protocol, dynamically assign IP address to client station at startup. Email. Simple email transfer protocol enables client to send email to a mail server, enables server to send email to other servers. Post Office Protocol version 3 or POOP3 enables client to retrieve email from a mail server, downloads email from the mail server to the desktop. Internet Message Access Protocol enables client to access email stored on a mail server, maintains email on the server. File transfer. File transfer protocol set rules that enable a user on one host to access and transfer files to and from another host over a network. A reliable, connection-oriented, and acknowledged file delivery protocol. Travel File Transfer Protocol, a simple connectionless file transfer protocol. Web Hypertext Transfer Protocol, set of roles for exchanging text, graphic, images, sounds, video, and other multimedia files on the World Wide Web. Transport Layer, User Datagram Protocol enables a process running on one host to send packets or process running on another host as that confirms successful datagram transmission. Transmission Control Protocols enables reliable communication between process running on separate hosts. Internet layer. Internet protocol receives message segments from the transport layer, packages messages into packets, addresses packets for end-to-end delivery over an internet network. Network address translation, translate IP addresses from private network to globally unique public IP addresses. IP support, Internet control messages protocol, provides feedback from a destination host to a source about errors in packet routing protocols, open shorter path first, link state routing protocol, hierarchical design based on areas, open standard integral routing protocol. Network access layer, address resolution protocol, provides dynamic address mapping between IP address and a hardware address. Point-to-point protocol provides a means of encapsulating packets for transmission over a serial link. Ethernet defines the rules for wiring and signaling standards for the network access layer. Interface driver provides instruction to a machine for the control of a specific network interface. The TCP and IP communication process. Open standards. Open standards encourage interoperability, competition, and innovation. They also guarantee that no single company's product can monopolize the market or have an unfair advantage over its competition. Internet standards. Internet society responsible for promoting the open development and evolution of internet use throughout the world. AIB responsible for the overall management and development of internet standards. Internet Engineering Task Force develops, updates, and maintains internet and TCP and IP technologies. This includes the process and documents for developing new protocols and updating existing protocol known as requests for comments documents. Electronics Communication Standard Organization. Benefits of using a layered model. The benefit to using a layered model to describe network protocols and operations. They each represent a basic type of layered networking models, protocol model, reference model. The OSI reference model, the TCP and IP protocol model, OSI model and TCP and IP model comparison. Packet tracer investigating the TCP and IP and OSI models in action. Message segmentation, protocol data units, encapsulation, example, the encapsulation. Network addresses. The network and data link layers are responsible for delivering the data from the source device to the destination device. The network address is the first address in a range of IP addresses and it is to communicate with all network devices on a particular network. Network layer source and destination addresses responsible for delivering the IP packet from the original source to the final destination, either on the same network or to a remote network. Data link layer source and destination address responsible for delivering the data link from one network interface card to another NIC. The IP packet contains two IP addresses, the source IP address and the destination IP address. The source IP address, the IP address of the sending device, the original source of the packet, the IP address of the receiving device, the final destination of the packet. Data link addresses. The purpose of the data link addresses is to deliver the data link frame from one network interface to another network interface on the same network. The IP packet encapsulated in a data link from that contains data link information, source data link address, and the destination data link address. Devices on the same network. The network portion and the host portion. Role of the data link layer addresses. MAC address is the data link address or the Ethernet MAC address to the bus that sends the data link frame with the encapsulated IP packet. Destination MAC address. The receiving devices of the same network is the sender device. The data link address of the receiving device. Source IP address. The IP address of the sending device, the client computer PC 192.168.1.110. Destination address, the IP address of the receiving device, the server. Let's proceed to the chapter 3. Let's go to the 3.2. Then let's proceed to first activity entitled OSI layer functions. In this activity there has two parts. The first one is OSI layer function. The instructions drag the OSI layer to its functional description.
contains protocol used for process-to-process communication. This is application. The next one is bit transmission. Is physical. Then the next provides a data path or route, is a network. Then exchanges frames between devices is data link. And the last one in this part 1 is segment transfer and resemble data is transport. So now let's check if the answer is correct in this part 1. Oh, you have successfully matched the OSI layer to its functional. And the part 2 is TCP and IP layer function. The instruction: drag the TCP layer to the functional description. Control hardware, device, and media. This is network access. And the next one is determines the best path through the network, is internet. Then the last one in this part 2 represent data to the user and control dialogues. So this is the application. Then now we can see if our answer is correct. Ulit then turn to page. Entitled Protocol Solid Instruct Directed Protocol or Standard to the TCP layer must describe. Una natin sasagutan is network access. Because network access have dual and dual layer. First is network access this chapter 3, there has 2 activity lang. But in the one activity, there's 2 parts.
Turn to page.
The packet tracer investigating the TCP and IPOC modules in action. The objectives is part 1, examine HTTP web traffic, and the part is display elements of the TCP slash the IP protocol suite. The background, the simulation activity is intended to provide a foundation for understanding the TCP and IP protocol suite and the relation to the OSI model. Simulation mode allows you to view the data contents being sent across the network at each layers. As data moves through the network, it is broken down into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination. Each piece is assigned a specific name, protocol, data unit or PDU, and associated with a specific layer of TCP or IP and OSI models. Packet tracer simulation mode enables you to view each of the layers and the associated PDU. The following steps lead the user through the process of requesting a web page from a web server by using the web browser application available on the client. The part 1 is examine HTTP web traffic. In part 1 of this activity, we will use packet tracer simulation mode to the generate web traffic and examine. And this is the topology of the packet tracer of chapter 3. So the step 1, switch from real-time to simulation. In the lower right corner of the packet tracer interface are tabs to toggle between real-time and simulation mode. Packet tracer always starts in real-time mode in which networking protocols operate with realistic timing. However, a powerful feature packet tracer. Click the simulation mode icon to switch from real-time mode to simulation mode. Then, HTTP may select HTTP from the event list lister. Click edit filter to display the available events. Edit filters. Then click the HTTP. Toggle the show all none checkbox and notice how the checkboxes switch from unchecked to checked or checked to unchecked depending on the current state. Tagging the show all none. Then click the show all none checkbox until all boxes are cleared. Then select HTTP. Click anywhere outside of the edit filters, hide it. So all the boxes are meron lahat checked. So we need HTTP lang yung may check. So kailangan natin i-unclear to, i-uncheck. Then, click anywhere outside of the edit filter box to hide it. The visible event show with the okay. Then the step 2. Currently, the simulation panel is empty. There are 6 columns listed across the top of the event list within the simulation panel. As traffic is generated and stepped through, events appear in the list. The info column is used to inspect the contents of particular event. The letter A is click web client in the pair left pane. So we need to click the web client, then after that click the desktop tab and click the web browser. Desktop, then web browser. After that, in the URL field, enter www.osi.local and click go. So copy, then paste here, then click go. So after that, because time in simulation mode is event driven, you must use the captured forward button to display network events. Click captured forward 4 times. There should be 4 events in the event list. So click the captured forward at 4 times. So 1, 2. So the message from web client is go to the web server, then 3, and go back to the web client, then 4. So as you can see, may lumabas dito na sa ating event list na for HTTP from web client. Then, step 3, explore the contents of the HTTP packet. Click the first colored square under the event list info column. It may be necessary to expand the simulation funnel or use the scroll bar. So click the first, then the PDU information device web client window display. In this window, there are only 2 tabs, OSI model and Outland PDU details. So this is the OSI model and this is the Outland PDU details. Then because this is the start of the transmission, as more events are examined, there will be 3 tabs display, adding a tab for inbound PDU. So ensure that OSI model tab is selected under the out layers column. Ensure that the layer 7 box is highlighted. So what is the text display next to the layer 7 label? The HTTP client sent the HTTP request to a server. Click next layer. Layer 4 should be highlighted. What is the DST port value? So the DST port value in the layer 4 is 80. Then click next layer. Layer 3 should be highlighted. What is the DSP IP value? DSP IP value is 192.168.1.254. Then click the Outland PDU details tab. So after that, information listed under the PDU details is reflected of the layers within the TCP model. Note the information section provides more detailed information than is listed under layer 2 on OSI Lab. The outbound PDU details provide more descriptive and detailed information. The value under DEST MAC and SRC MAC within the Ethernet 2 section of the PDU details appear on the OSI model tab under layer 2. So after that, click the next colored square box under the event list. Only layer 1 is active. So click the second. So as you can see, the layer 1 is the only active. Then This device is moving the frame from the buffer and placing it on the network. Advise to the next HTTP info box within the event list and click the colored squared box. The window contains both in-layer out-layer notice after that, click the outbound PDU details tab, control, scroll down to the HTTP section. So this is the HTTP section. What is the first line in the HTTP message that display? The accept language, connection, the host www.osi.local, then click click the last colored square box under the info column. How many tabs are displayed with these events and why? Let's see. The part 2 display elements of TCP/IP protocol suite. And the step 1 view additional, close any OpenPD information window. So close, then do that. In the event list filter, visible events show all. So show all. HTTP. So as you can see, there has a DNS, ARP, and TCP and HTTP. So then click the first DNS event in the info column. Click the DNS. So explore the OSI model and PDU detail tabs and note the encapsulation process. OSI and PDU detail. So yan, ito yung OSI model. Has an in layers and out layers, the outbound. Then as you look at the OSI model tab with layer 7 highlighted, a description of what is occurring is listed directly below in the in layers and out layer. The in layer has no highlighted layer, while in the out layer there has a 1, 2, 3, 4 highlighted layer. Layer 7, 4, 3, and 2. Click the outbound detail tabs. Click, then what information is listed in the name in the DNS query section. The name in DNS is the www.osi.local. Then click the last DNS info colored square box in the event list which device is displayed. So click the last DNS. So this is the last DNS. So what is the value listed next to address? So yan, next layer. Device encapsulation and UDP. So next, find the HTTP event in the list and click the colored square box at the TCP event immediately. Find the first HTTP. So this is the first HTTP. Highlight layer 4 in the OSI model tab. So yan. So the next hop IP address is unicast. The IRP process looks it up the IRP table. The next hop IP address is the In the IRP table, the IRP process sets the frame destination MAC address to the one bound in the table. The device stops the PD in the Ethernet. So click the last TCP event. So click the last TCP event. So highlight layer 4. In the SI model, examine the step listed directly below in layer 4 and out layer. What is the purpose of this event? Based on the information provided in the last item in the list should be item and 4. So I click the layer 4. So as you can see, ito yung lumabas. The device received a TCP ACK segment on the connection to 192.168.1.1 on port 1025. Receive segment information, the sequence number 104, the ACK number 273, and the data length 20. The TCP segment is the expected peer sequence number. And the last, the device sets the connection states to close. So, yan. So, and that's all in the chapter 3, Packet Tracer, entitled Investigating the TCP and IPO and the SI models action. Thank you for watching. I hope you enjoy and you learn in my video. So bye.